With Shift to Rail, we are able to test our technologies with international partners. Here in Sweden, we work with the infrastructure operator Trafikverket.
My name is Mattias Asplund. I work for the Swedish Transport Administration Trafikverket, and I'm really glad to be here and see this demonstration of the tamper.
We brought this tamping machine to the south of Sweden in collaboration with Trafikverket and Infranord to test the two systems in the tamping machine. One is the tamping unit equipped with several sensors that allow us to get information about the ballast, and the stereo cameras that allow us to get the absolute track geometry.
Various sensors on our tamping machine for testing purposes allow the tamping units to sense the ballast. For this, we have attached strain gauges to the tamping tines. Via the strain, we can infer the forces during penetration and during squeezing. This is important for further improving our system and for detecting the ballast condition. Is the ballast new, or does it have a high percentage of fine grains and must be cleaned? Plus, angle sensors on the tamping unit allow us to precisely measure the squeezing distance. Acceleration sensors on the tamping unit and the machine frame allow us to observe the movement behavior during tamping. More sensors are distributed on the hydraulic system.
For this test, we chose, together with Trafikverket, 8 different sections where we will get information regarding the status of the ballast. These sections had different superstructure and ballast conditions. Also, in one of these sections, we equipped the poles with markers, which allow us to get the absolute track geometry.
Here on the machine is the absolute track geometry measuring system. A measuring frame is the basis for the inertial measurement unit. With this, we determine the relative track geometry. A stereo camera system measures the distance from the machine to the measuring point. Using QR markers, we identify the points and calibrate them directly when the machine is passing. The relative track geometry, together with this measuring system, allows us to create an absolute track geometry file from the relative track geometry file. This is particularly important for high-speed traffic, where deviations should be as small as possible.
This is a collaboration in the European project Into Track 3. We will improve our maintenance in the future by improving the tamping parameters for more efficient work in the future.